Hello everyone, this is Hariom Singh and we are TLE Eliminators. Today we are going to discuss the CodeChef Starters 230. So let's get right into it. Problem A, reselling items. So chef is trying to buy some items from a store and then resell them elsewhere to make profit. For the ith item, chef knows that he can resell it for AI coins. The store has an ongoing offer. The first key items that chef buys will be offered at a discount of 5 coins each, but the remaining items will be offered at 10 coins each. Chef can choose to buy any number of items and in any order that he desires. What is the maximum profit chef can make? So basically, in this problem, it states that you are given an array A and there is a shop from which you can buy items. The first key items that you buy from the shop, they will cost you 5 coins, and the rest of the items that you buy, that will cost you 10 coins, right? Then you can buy the items and then you have to resell them at the cost of AI, right? So let's just model this problem, right? So basically you have an array A, and in this array, the first k elements, you can obtain all of these first k elements at the cost of 5, right? And the rest of the elements, that is n minus k, you can obtain them at the cost of 10, right? Then what you have to do is that these are the costs at which you buy, right? This is the cost that you buy at, right? Now what is the problem telling you? You can then sell each item at a cost which is given to you at as an array A, right? So let's say that you can sell an item at cost 20. The first item that you can sell at cost 20. The next item you can sell at 5. Then the other one you can sell at 1, or maybe let's say 2, or you can, let's say, some item you can sell at 100, right? And what they're telling us to do is that we have to maximize our total profit, right? So one very simple observation that you can make here is that if any item from this cell array, if its value is lesser than 5, then we cannot do anything, right? Because even if we buy it at 5, it is never optimal for us to sell it at 1, because that will be our disadvantage, right? We will not gain any profit. So look at some test cases here, right? Let's look at some test cases. Let's look at the first one, right? 15, 15. Here you can notice that you can buy both the items at the cost of 15. Sorry, sell at 15, right? And the value of k is 1. What does this mean? It means that you can buy exactly one item at a cost of 5 and the other item at the cost of 10. So what is the optimal thing to do? Greedily, you should choose to buy the item 5 and the item 10. Since both of them are same, the answer is going to be equivalent, because it doesn't really matter. So the profit that you accumulate will be, if you sell at 15 and you buy at 5, then the profit one will be 15 minus 5, which is 10, and the other profit will be 15 minus 10, which is 5, and the sum of both of these profits is actually equal to 15, right? So the answer for the first test case should be 15, right? It is 15. Let's look at some other test. Let's look at this one, right? The value of k is 10, so it covers everything. It's not that helpful. Let's look at this one, right? If you look at this test case here, you see that there are exactly 3 items that you can, you know, buy at a cost of 5 and the rest two items will be bought at the cost of 10. So my claim is that in the greedy strategy, our greedy strategy should be that we should buy at as many items at the cost of 5. We should try all the items that we buy at a cost of 5. We should sell them as high as possible, right? And this is very intuitive as well, because in order to accumulate more profit, you should sell low, or you should sell high and buy low. So what's optimal thing to do is the items that you are buying at 5, you should sell them at the highest price, right? So what we can do here is that we can just sort this array. So if we sort this, and obviously in the reverse order, so we can write 12, 10, 7, 6, and 3. So this is going to be my order in which I am going to sell those items, right? And now I can say that the first three items, right, the value of k is 3. So I can say that the first three items I should buy at 5, right? So this will be bought at 5, this will be 5, this will be 5, and the rest of them will be at 2, will be at 10, right? Now notice here that what is our total profit? Let's denote it by profit. This is equal to what? We are selling at this cost, right? And we are buying at this cost, right? So our profit will be, for this one, we'll have 12 minus 5, which is 7, plus in this case, we have 10 minus 5, which is 5. In this case, we have 7 minus 5, which is 2. And now notice here, as I already claimed above, it is not optimal for us to sell at 6 and buy at 10, and similarly sell at 3 and buy at 10. So we can just ignore them. So the answer for this will be 7 plus 5 is 12, 12 plus 2 is 14. So answer for this test case should be 14, right? So look at the answer here. Yeah, this one is 14. So the strategy is pretty simple. What you had to do is that sort the array A, which represents the price at which you are selling, and try to sell as many items at the cost of 5, and then sell other items at the cost of, sorry, buy other items at the cost of 10, right? Is this clear? So the implementation is also very simple. So what I did was I just took the array and then I reverse sorted it. And what we have to do is that the first k items, I have to buy them at 5, and the rest of the n minus k items, I have to buy at the cost of 10, right? And obviously, if my value that I'm selling at is lesser than the value I'm buying at, then I should ignore this item, right? It's never optimal for me to sell it because I'll get a negative profit, which is not optimal, of course. So I do max of 0 with this value, that is my profit accumulated, and I sum all the profits and I print it. And this is essentially done. Correct code, right? Is the implementation and the uh, idea clear? Stack for C. You can do stack for C, but I did set. Today's contest is hard. It's not hard. It's more like ad hoc. So I hope this problem A is clear. So let's move to problem B. The audio is fine, right? Okay. Okay, this problem. Uh, Sets differ by K. Okay. For a permutation P and an integer K, we define f of Pk as a set S formed by the following process. So basically, we are just forming a set S using some algorithm, right? Initially, set S is empty. Then for each I from 1 to n, check if there exists some element x which belongs to the set S such that absolute difference of x minus pi is less than or equal to k. If this condition is true, if some element x is found, then append s pi to s if and only if there does not exist any x, right? So if you found this some number x belonging to the set S, then you should ignore it. Otherwise, if you are not able to find any element x, then you should append it to the set S, right? Append it to pi. Append this element pi to the S, right? Then you're given a set of elements S represented by a binary array B of size n. Here x belongs to the set S if and only if bx is 1. So basically, you're given a binary array form in which if the bit is 1, it means that that element is present in the set. Otherwise, it is absent, right? Does there exist a permutation P such that f of P of k is actually equal to S? Otherwise, you just have to print yes or no. So basically, a pretty complicated problem statement. What they trying to tell us is that there is there is some set S, right? Initially, which is empty, right? And what you have to do is that suppose there is some permutation P also. You have to basically choose elements in the range from 1 to n, right? These are the indices. Then you choose the element present at the corresponding index of p of I, and then you check whether in the set S some element is at a distance of absolute difference of at a distance of less than or equal to k. If it is so, you just ignore it. Otherwise, you just append it to the set S. So the problem statement will be much more clear if I show you some test cases. So let's look at this one, right? So let's look here, right? The value of n is 3 and the value of k is 1. And what this tells us is that these are indexed, right? So this means that my set contains of elements 1 and 3, right? Right. And the value of k is 1. So we just have to tell whether we can make this set S or not, right? Or in other words, does there exist some permutation P such that we are able to obtain this set S or not, right? Okay. So let's look here. So suppose what is this telling what is trying to tell us is that suppose if you have some element x equals to 1, then you can notice that this element 1 can be inserted into the set freely because there is no such constraint, right? When you move to element 2, right, when x is equal to 2, what happens is that in the set you already have an element which is equal to 1, right? And if you see here, if you try to insert this element 2, then the difference of 2 minus 1, this absolute difference is going to be 1, right? And which is bad. Why? Because we do not want the difference to be less than or equal to k, right? So we do not want this difference to be less than or equal to 1, but it is already equal to 1. So we cannot insert 2, right? So 2 is kept. So 2 is not inserted and 1 is inserted. Now look at the element 3. If you look at x equals to 3, right? If you look at x equals to 3, then you notice the element present in the set is 1, right? And the absolute difference between 3 and 1 is what? This difference is actually equal to 2, right? and this difference is greater than k. So you can insert this element, right? Because we want, if this condition is true, we cannot insert it. But if the inverse condition, that x minus pi is greater than k, then you can insert the element to s, right? So this difference 3 minus 1, which is equal to 2, is actually greater than k, right? 2 is greater than 1. So you can insert this into the set. So 3 is inserted, right? So what is our set? Our set is equal to 1 and 3, right? And we did not run into any discrepancies, so it's fine. So answer for this test case should be 1. Should be yes, right? Now look at the second one. They're similar, but the answer is no. Let's look at the difference. Why? So the set is s equals to 0, 1, and 1, and the value of k is also 1. Now, what does this represent? This represents that the elements in the set are 2 and 3, right? So we have to check whether 2 and 3 are consistent with each other or not, right? So how do we do so? Suppose we insert 2 into the set, right? So suppose 2 is inserted. Now what do we have to check here is that when we try to insert the element 3, right? If we choose that the value of x that we are trying to insert is 3, right? Then in the set 2 is already present. So we'll check the absolute difference between 3 and 2. So this difference will come out to be 1, right? And we do not want this difference to be uh, equal to 1, right? Why? Because we want this difference to be greater than 1, but it is equal to 1, so we cannot insert 3. So since 3 cannot be inserted into the set, we cannot obtain 2 and 3, right? So this is not fine. So the answer for this test case should be no, right? Now look at some different test case. Let's look at this one, right? Here, notice that the elements of the set are what? 1, 2, 3, 4, 5, 6, 7. So the elements of the set are 1, 4, and 7, right? So they are telling us that these should be consistent with each other. So let's suppose we insert the element 1 into the set, because 1 does not have any constraint, right? So 1 is inserted. Now we have to check whether 4 and 7 can be inserted or not. So let's say that x is equals to 4. Then what is present into the set is 1. So we check whether 4 minus 1, this difference is equal to 3, right? Which is greater than 2, the value 2, right? This is greater than 2, so it's fine. We can insert the element 4. Now look at x equals to 7. Now we have to check whether the difference between 7 and 1, right? We have to check 7 with both 1 and 4, right? So the difference between 7 and 1 is 6, right? This difference is greater than 2. Also, 7 minus 4, this difference is 3, which is also greater than 2, right? So both of them are greater than 2, so we can insert 7. Now notice here that we do not really need to check 7 with 1. Why? Because 7 is more closer to 4, right? So if the difference between the element which is more closer to 7 is already greater than 2, already greater than 2, yes, then we do not need to check further, right? So this is also consistent. So answer for this test case should also be yes, right? But there's some sneaky thing happening, right? So let's look at that. Suppose that if in this case we are able to make 1, 4, and 7, right? So this till this everything is clear, right? for this problem, the expected rating should be, it should be 1200, I think, or maybe a little bit more or less. I don't really know. Okay, so till this is fine, right? Now, notice here that we checked whether all the elements that are going to get inserted into the set are fine or not. Now we also need to make sure that the elements which are not present in the set, they should not get into the set, right? So what I mean by that is, suppose you have an array A, right? And X is already present into the set, right? So this is your initially element X, right? Which is present into the set. Now suppose that I am inserting an element Y, right? So I'm trying to insert Y, right? This is my to-do task, that I have to insert element Y. So can you tell me that what should be the condition that I should be able to insert the element Y into the set S, right? When should I be able to do it? I should be able to do it if and only if and only if the difference between Y minus X, this value should be greater than K, right? So this is one thing, right? Also, now suppose the value of X was, let's say, equal to 3, and the value of Y was, let's say, very big. Let's say that this was 15, or let's say this was 20, right? And the value of K was 5, right? Now notice that suppose the set already contains of 3, right? Now you want the next element that to get inserted into is 20. So obviously 20 minus 3, right? 20 minus 3 is going to be greater than 5, right? So we can insert 5 into the set. But if you notice, all the numbers between 3 and 20, are they, will any of them also get inserted into the set? This is also you have to check, right? If any of the element between 3 and 20 will also get inserted into the set, then it's not good, right? Because we only want 3 and 20 into the set. So let's say if we choose an element, let's say a random element, let's say 15, right? And if we check whether 15 can get inserted into the set S or not, right? This is our set. So for 15 to get inserted into the set, we will check whether 15 minus 3, right? This value is greater than 5 or not, right? And this is true. So 15 will get inserted into the set, right? Now we did not want 15 into the set, but it also got inserted, right? And now 20 cannot get inserted. Sorry, 20 will also get inserted because no, 20 will not get inserted because 15 will create problems for it, right? Because we already saw here that in order to check whether some element can get inserted, we just have to check the closest element to it, right? So suppose 15 got inserted, then we will check for 20, then 20 minus 5, 15, right? This will be equal to 5, right? And we, this condition is not holding now, so 20 will not get inserted. So even though it initially looked like 3 and 20, they are compatible with each other, but they are really not, right? So what do we have to do now? So the claim that so this example is clear, right? Yes. Okay, so if this example is clear, then we can notice, we can just create one maybe a visualization, is that suppose if I'm inserting an element X into the set, then I cannot insert anything from here till here, and this range is actually equal to 2k plus 1, right? So I cannot insert any element in this range, right? So this should be x minus k, and this should be x plus k. right? If any element that comes into the set, right, if it tries to come into the set, let's say y, if this element y falls in this range, then it cannot get inserted, right? So one condition is this, that for suppose, so let's take an example. Suppose x is equal, sorry, k is equals to 3 and x is equals to, let's say, 5, right? Then for the element 5, you can notice that all these things, 3, 4, 5, and you have 6, 7 and 8, right? All of these elements, they cannot get inserted into the set, right? So basically, I can just mark visited that if any of the element tries to come and it falls into this range, then it is not optimal, right? Second thing that you have to observe, this is one idea. The second idea was that if there are two elements already into the set, right? Suppose they were x and y, right? So we already saw that they will create some kind of ranges, which will say that you are not allowed to come here. And let's say another element is the y, right? And its range is a little bit shorter, let's say from here to here, right? No, they will not be shorter actually. They will be of the same length because k is fixed, right? So this is k. Now notice, suppose there is a gap here, right? Suppose there is a gap of 2 or let's say 3, right? Now notice that when we are iterating from 1 till n, you will insert x into the set, right? You can insert y into the set, but you will notice since this creates a gap, so suppose the value of x is, let's say, 5 and this value is 15, right? And the value of k, let's say, is 3, right? So this rightmost range of x will be 8 and the leftmost range of 15 will be 12, right? And the elements in this range, right, 9, 10, 11, 12, right, 9, 10 and 11, they will also get inserted into the set, right? Because for an element, let's say 10, you just saw that 10 minus 5 is greater than 3, right? So it will get inserted and it will create problems for 5, and we did not really want 10 to get inserted, right? So the another condition that we have to satisfy is that for every adjacent element which is already present into the set, this difference should not be more than or equal to 2k plus 1, right? Because this is distance is k and this is k, and this one more, right? So it should not be greater than or equal to 2k plus 1, right? This is condition 2. And another condition was that that two adjacent elements of the set, they should be greater than or equal to greater than k, strictly greater than k, right? This was condition 1, right? So if all the elements of the set for all possible pairs of y and x, if they satisfy both of these conditions, then you're good to go. Otherwise, the answer is no, right? Clear, right? Okay. So this was it. Basically, you just had to see that. Okay, one clever thing that they did here, or maybe sneaky thing that they did here, is that if you do not if you do not incorporate this thing, this second observation into your code, then your samples will pass actually, right? And you will think that this condition is sufficient, right? So I also got a WA for that, and you have to be a little bit more conscious while writing the code, right? And making observations, obviously. So let's look at the submission. So basically, for the binary array, I have to convert it into a single array. So basically, if an element x is 1, then I can say that this element is present in the set, right? Now notice that if the set is empty, then obviously this is just a trivial case. You can notice here uh, that in this case, here all the elements are 0, right? So the set will be empty, but this is not possible because at least one element can get into the set, right? Because inserting one element does not create any problem for any other element, right? So this is the answer for this case should be no, right? So if this is empty, then the answer is no. I'll explain these two conditions a bit later. So let's look at this one. For every adjacent pair of elements, right? Obviously, I'm inserting in order, so they will be sorted. So I do not need to sort the array array B. Now notice that for every adjacent pair, two conditions should be true. The first condition is the adjacent element difference should be greater than k, and this adjacent element difference should be less than or equal to 2k plus 1, right? So both of them are incorporated here, and I just print whether all of them satisfy or not. And these two conditions are also necessary. Why? Because we are inserting in the order from 1 to n, right? So notice that if let's say value of k equals to 3, right, and the first element that you want into the set is 4, not 4, let's say 5, right, and you want to insert the element 5 into the set. Now notice when you're iterating from 1 to n, what will happen is that you do not want the distance to be less than or equal to k, right? This distance should be greater than or equal to k. So you have to insert at least one element in the range from 1 to k, right? So the first element should be in the range from 1 to k. Similarly, for the last range, you can also mirror this fact that from the last range, from n minus 1 to n minus k minus 1, you should have at least one element, right? Because of the same facts as I already explained above, right? So I incorporate that the first element should be from the range 1 till k, and the last element should be from the range n minus k minus 1 to v dot back, right? These are essentially the same things, right? So this was the implementation part for the problem B. Is this clear? Okay. C major implementation was tougher than D. Yes, C was tougher than D. I got stuck on D too, I think so. I got really stuck on this problem. Okay, let's look. Okay, so we have solved this one. Let's look at the other one. Sum of second maxes. This was a good problem, or maybe a little bit standard, but I don't know. So in this problem, let's read it first. Sum of the second max. For an array B, we define f of B as the second largest element of the array, right? For example, if you have the array as 2, 4, 5, 1, the second largest element is 4, right? The first largest is 5, second largest is 4, right? So the second largest value is 4, right? You are given a permutation array A of n integers, each element from 1 to n. You have to compute f over all the subarrays of size at least 2. So this is the mathematical formulation, right? So basically, you're given an array A. The constraints are normal, like 2e5 and the values are from until n. What you have to do is that you have to go to every subarray, find the second maximum element, and then sum that for every array, right? So basically, it's saying that suppose you have an array A. Let's say it is 3, 4, 2, 1. Right, then what you have to do is that go to every subarray, right, of size at least 2, of course. So suppose you choose this array, the second maximum element is 3, so you add your result, so you add 3 to your result, right? You add 3, Then suppose you choose this array. The second max is 2, so you add 2. And if you choose this array, the second max is 1, right? This is done. Okay. Now notice this, that if we choose this array of size 3, then the second max element is 3. So we'll add 3. Now suppose if we choose this array, then second max is actually equal to 2 because 4, 2 and 1. Then you'll add 2. Then the final array that you're left with is the complete array, right? The second max of which will be 3. So you add 3 to your result. So whatever you get here, you have to print that, right? Right. So okay, so what this is what we have to do, right? So initially, so this is pretty generic idea. Whenever you are told to, find some kind of these kind of results where you have to go to every subarray and apply some function to it and result and then add the result to your answer, it is generally the case that you have to look not at the subarray but the contribution of each element that it gives to the final result, right? What I mean by that is that if you look at the array, right? I'm telling you that what is the contribution of 3 to your final result, right? What does it mean? To say that what is the contribution of some element x, it's denoted by cont of some element x, what will it be? It will be all those ranges in which x is actually the second maximum element. Is this clear? Right? So what we have to do is that find a range in which the element x is actually equal to the uh, second max, right? So suppose if we choose x as 3, right? Then what are all the subarrays in which 3 is the second max? Then they are 3, 4. What else? You have what did you call 3, 4? Then you have the entire array 3, 4, 2, and then the entire array 3, 4, 2, 1. So what you can do now is that for element 3, you can notice it contributed to 3 subarrays. So what you could have done is that you could have multiplied 3 with its contribution and add it to your result. So this 3 denotes the value 3. This is the value. And this 3 denotes the contribution, right? And we can repeat this process for every element of the set, for every element of the array, right? If we do this and add the entire thing to our answer, then the whatever we get at the end is is the final result, right? So is this idea clear? Yeah, the number of subarrays is greater than x and previous max. Yes, we'll get to that. So all that's left for us to do is that to find those ranges in which an element x, for any arbitrary element x, that element x should be equal to the second maximum. So how can we do so, or what is the way? So an element x will be second maximum in a range if and only if some other element, let's say y, is greater than that element x and no other element is greater than x, right? So what I mean by that is, suppose let's look at some other problem that says that you have to find a range in which the element x is the largest. So suppose you have 5, 3, 1, 2, 4, 7, and let's say 6, right? And now suppose you're trying to find the range for which 2 is maximum. No, no, not 2. Let's say 3 is maximum, right? So we are trying to find the range in which 3 is maximum. So can we go left? No. Why? Because 5 is already greater than 3, right? So we try to take 5, then 5 will dominate 3. So 3 will not be the maximum element. So we cannot go left. So the left range for 3 is fixed, right? So this is fixed. Now suppose in the right range we have to iterate as long as the element 3 is maximum, right? So is 3 greater than 2, right? 3 is greater than 2, so we can move forward. Is 3 greater than 3, sorry, 3 is greater than 1, so we can move forward. Is 3 greater than 2, so we can move forward. But 3 is not greater than 4, so we have to stop here, right? So this is the range in which 3 is actually equal to the max, right? Now similarly, let's say for if we are trying to find for 4, then we can notice that, let's copy this, and we can notice here, if you see, if we are trying to find for 4, then you can notice we cannot move further ahead for 4. So we'll fix the range for the right range for 4, then we'll hop to 2. We'll see that 2 is lesser, then 1 is lesser, 3 is also lesser. So we got till here. Then you notice that 5 is greater, so you cannot expand to 5. You have to set this range, right? So this is the range in which 4 is the max, right? So this is the intuition part for finding the maximum element. What you can do is just iterate over the ranges, keep 2 pointers and something like that. But in order to find the second maximum element, what you have to do is that if at any point, for let's say for this element 4 only, if we have to find the range in which 4 is the second maximum, then you notice, when did we stop at any point? We only stopped when we found an element which was greater than 4, right? So if you look at this range, if we move any step in one direction, either to the left or to the right, we'll run into an element which will be greater than 4, right? So here notice that 5 is greater than 4, here 7 is greater than 4. So you cannot choose 5 and cannot choose 7. But if you choose 5, then 5 will become the largest element and 4 will become the second largest element, right? So this is the case. So either you can move from, you can either choose 5 here and expand your range, or you can choose 7 or expand your range. So basically you have two cases, right? Either you choose 5 or you choose 7. So in order to find the second maximum element, second max range, what you have to do is that you have to find the range in which this element L, let's say for element X, we are finding the range where this L denotes the index, where this is the uh, index of the previous greater element, right? And what you do now is that we do not have to stop at this index. We have to also find the second previous index, or second the previous to previous greater index, we can say that. So suppose for this array, if say let's say x was 4, these were 3, 2, and this element was 5. Now in the other range, suppose this was 1 and this element at the end was, let's say, 7, right? This was one case. Now suppose these elements are also so basically let's just assume this was not a permutation and the elements could have been negative. So suppose this was -1 and 0. Then for R, suppose this element was, let's say, 10. So we found the range where 4 matches with the previous greater element and the previous to previous greater element. Similarly, in the right range, you found the next greatest element, and suppose the other element, let's say this one was -2 and -3, and then you got, let's say, 11, right? Then you match 4 with 11 as well, right? So suppose if by some algorithm or by some means I found this range, right? So what is going to be my contribution for 4? The contribution of 4 will be what? Either you choose any element from this set, right? Uh, Either you can choose, wait, what? You have to find the range in which 4 is equal to the second max, right? So we have to choose at least one range in which 4 is equal to the in which you find at least one element which is greater than 4. So that will be, you can choose any of these elements in this range. That is, suppose this was L1 and this was L2, right? And this was R1 and this was R2. Then no, notice they form multiple ranges, right? So let me mark them. Suppose this was one range, and suppose this was the another range. Now the contribution of 4 will be what? I have to choose at least one element which is greater than 4. Then I can choose from this range, that is L1 minus L2. And what I also have to do, I have to find the position of 4, right? And I have to choose at least any L point from here, right? My L will be here, and from my R will be here, right? So if I choose any value R from this range or any value L from this range, and I make an interval, then it will contain X, right? And we will get at least one element which is greater than 5 or greater than 4, and all the elements which are lesser than 4, right? So 4 will be the second maximum element, right? So we can multiply them. So my answer will be either equal to L1 minus L2. So this gives us the left range for L, multiplied by what? You have to take the contribution where 4 is not the maximum. So we'll take R1 minus the position of, uh, or maybe let's say the index I at which 4 is initially present, right? So this is one contribution. Now similarly, you can look at the other case where my L will be in this range, right? This will be my L's range, right? And this will be my R's range. So you can do R2 minus R1 multiplied by I minus L1, right? Similarly to this equation, right? So that will be R2 minus R1 multiplied by the position of X, that is I minus L1. So these were actually the count of subarrays in which X was the second max, and you have to find the result. So you can just add them and multiply this answer by X and add this entire result to your answer, right? So is this clear? Is this idea clear? Yeah, this idea is pretty much generic. So this idea is used in multiple problems. So you should maybe take a note here, right? So so since the idea is clear, the implementation part is also pretty well known. Either you can use a stack, or people use a segment tree to find the range in which the element is maximum, second maximum, right? Or you can do some clever set thing. So I did the set. So basically what I do is I iterate from right to left, right? So what I mean by that is I iterate from n to 1. So in the reverse order, what you do is that you just find the position of the element, right? And what you have to do now is that you just have to take lower bounds or maybe binary search on the positions of the next greater element and the next smaller element. So you can do, so suppose in the set you have the position of all the elements, right? So in order to get to the position of the next greater element, we have processed only the bigger elements, right? So to get to the position of the next greater element, you can do lower bound. So that will give you R1 for this element X. And then you can do lower bound on this one as well, right? That will give you R2. Now again, you can do binary search that you can do previous of this. So that will give you L1 and then previous of that. So that will give you L2, right? So this is the set thing. So basically all the elements are greater, right? So you can do binary search or lower bounds and upper bounds on the set. So this was one implementation, right? So let me show you the code. Where is it? So implementation is pretty simple, but I have to do, so basically I have to know the position of the element, right? So I took the input and I stored the position of all the elements. Then in the set, this makes the life a little bit easier. So basically you have to find the uh, next element and the next to next element, right? So what you can do is that if suppose some element you run into some element 1, right? Or suppose that you run into some element n, right, which is already bigger. So the position was n. If you do upper bound on it, then you'll go out of the range, right? And then you'll have to handle those cases in which you run into set.end, right? So in order to fix that, what you can do, you can just insert n plus 1 and n plus 2 into your set, right? Because if you do so, they just mark that these elements were already these elements were the boundaries, right? And you can just check that adding these two elements does not really affect your answer. And similarly for the left hand, if you have some element 1, then you can set 0 and minus 1 to your set, right? So this is essentially saying that very large values are already present at the end of the array and at the beginning of the array, right? So this makes an implementation a little bit easier. So now what you have to do is just iterate from n to 1, right? You have to find the index of the so basically this is what I was saying, that the next greater element will store at this iterator index that will be equal to your uh, so that will be equal to your next greater element r. Then you jump to the next of this iterator, that will give you to the next to next greater element. Now if you jump to the previous of that, that will give you the previous greater element. And if you jump to the previous of that, that will give you the previous to previous greater element, right? So now you have all the 4 elements. Now you just have to apply the formula that we saw here, that L1 minus L2 into R1 minus I is actually the position, right? So L1 minus L2, L2 is LL into R minus the position, and similarly R2 minus R1 into I minus L1, right? That is that. And you just insert this element into the set. So this is it for the implementation part. And you might get the doubt that why are we iterating from n to 1? That is because the way we have defined the set, you in the set you have to find the position of the next greater elements, right? So in order to get to the next greater elements, the position of those elements, you have to know those positions, right? So that's why we process the bigger elements first and the smaller elements at the last, right? Is the implementation clear? just a pupil. Okay. Yeah, for D, I also got the gut feeling, but yeah, there's no. Actually, I do not have a very formal proof for that as well, because if you know that, how do you actually get from this array? So let's read the problem first, right? Then we'll discuss that. D1, which is A to B easy version. You are given two binary strings A and B, both of length n. You can perform the following operation on A multiple times, possibly 0. Choose L and R such that they are from 1 till n, and flip all the values in the subarray from L to R. Right. So this the cost for this operation is 1 if the extreme values, that is A of L, is equal to A of R, and otherwise it is 0. Right. Flipping a value means changing it to 1 if it was 0, and vice versa. What is the minimum total cost of transforming A to B? Right. So basically, you are given multiple binary strings. So suppose this was 1 0 1 1 0 1 1 0 1. Right. So this was your string A. Then what you can do is just choose two points which have different endpoints. So suppose this was 1 0, then you can choose any range such that they are different. So this was 0, this was 1. Then what you have to do is just flip all those bits in this range. So 0 becomes 1 and 1 becomes 0. This will become 1, this will become 0, 0, 1, 0, 0, and this they will remain same. So this is 0, this is 1, right? But and this operation will cost you 0 because you chose two points which had different endpoints, right? Which had different extremes, right? But if you choose any two points which have the same endpoint, right? So if you choose this range where this is 0, and let's say this was also 0, then 0 and 0 are same, you'll get the cost 1, right? So this will give you a +1 cost. Now you'll get, sorry, this will be 1, 1, 0, 1, 0, 0, and 1. This will give you a +1 cost, but while this operation, because you choose different extreme points, you'll get a +0. So what you have to do in this problem, you are given two binary strings. You can perform the operations on array on string A. You have to convert it to a string B while minimizing the total cost. Right? Is the problem statement clear? Okay. So basically, one observation that you can make from the test cases as well is that the total cost is not greater than 1, but it does not really say anything much. So let's look at some cases. So this first case was that you had string A as 0 1 0. This was your A, and then you had B as what, 1 1 0. Now you have, if you want to convert A to B, then notice that it can be done in one step. How? So suppose in this case, what we can do is that choose two points which have different endpoints, right? So you choose this range, then you flip values in this range. So A will become equal to 1, this will become 0, this will become 0, and B is going to remain the same. This will become 1, this will 1, and this will be 0. Right? Now wait. Okay, this they had given something, right? I chose different points. let's let's correct this. Now here they're saying that you should choose ls2 and rs3. So this, but this is same. Okay, fine. So a will become equal to what? This will become 0, this will become 0, this will become 1, and b is equal to 1 1 0. Now you can choose the entire thing. So from here a will become equal to 1 1, this will become 0, this will become 1 1 and 0, right? So this is what they have to do. So this can be done in the cost 0, because we never chose any 2 points which had different endpoints, right? So now let's look at some basically in this problem you just had to run samples and then make some observations, right? So one thing is that, suppose one observation that you can make here, if all the elements, right, all the characters of some string is, let's say, 111 or 000, right? Suppose this was 11111 and b was 10110, right? Then you have to perform at least one operation in which you have to make a cost of, you have to take a cost of 1. Why? Because in every point that you choose from this array A, what will happen is that all both of these points are going to remain same, because all the points are going to be same. So at least one operation will be there, or any operation of the first operation that you make will force you to get a cost of 1, right? So you can just choose any range, or let's just choose this range, right? Let's choose for converting this to this. If we choose the first element, then our a will become what? Will become 0, and rest of the things will remain same, right? While b will be the same thing, 10110, right? And now we have a cost of 1. So this is one thing. Now we have converted a to a normal string which contains both 1 and zeros. Now this idea is also applicable to the string b, right? If we have a normal string consisting of ones and zeros, while the string b has only zeros or only ones, we have to make an operation, at least one operation on the string b to make it a normal string, right? And why are we going to make us? We are not allowed to make an operation on string b, right? But it is pretty simple to observe that if you are able to convert a to b, then it is also able to make operations on the array b, on the string b, and convert it to a, because they are symmetric, right? The performing of flipping operation of on the string is actually the same, right? Either you convert a to b or you convert b to a, or you can say that, and and you can also say that if they are both able to convert to some string c, then if they're both able to read some string c, then it is also convertible from a to c and c to b, right? This was also one idea. So let's just choose one random string, uh, right? Let's just say a is 10110 1, let's say 00, right? And b was 010000, and you have, let's say, 101, right? This was a, then this was b, right? So they are pretty complicated strings. Now let's see if we are able to convert a to b in zero cost or not, right? So in order to get zero cost, it is always obvious thing to do is that we have to choose two different points such that they are on they have different indices, right? So let's just choose L as this, and let's choose let's say choose R as this, right? Because this is 1 and this is 0. So what we can do here is that A will convert to what? A will convert to 0. So we are able to match these. Then this is 0, so this will become 1. This will become 0. This will become 0. This will become 1, 0, and 1 and 0, right? Now this is our set of A and B's. Now notice that this has matched. So we can safely ignore this. And now what we have to do is that we just have to perform an operation here. So this will become 0, 1, 0, and 1, right? So this is it, and this is also matching with this. But on the other hand, if we have some string like 1, 1, 1, 1, while B is, let's say, 0, 0, 1, 1, then notice that we have to perform at least one operation in order to make A to B. So our first operation will definitely be equal to, let's say, we choose some point, let's say we choose the point 1, right? This is the range. Since L is equal to R, so we'll get a cost of 1. This will become 0. And so obviously you can choose this, right? This range, right? So this will definitely convert to 0, 0, 1, 1. So let's choose different method, right? So 0, 1, 1, 1, right? And you have B as 0, 0, 1, 1. Now what you have to do is that convert this 1 to a 0, right? Because all the other things are matching. How can we do so? There definitely exists some uh, method by which we are able to do so. Let's think about that. This is 0, 1, 1, 1, and this is 0, 0, 1, 1. We have to choose two different points. So if we choose this point, then we'll have 1, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, right? And if we choose this now, then we'll have 0, 1, 1, 1, and we'll have 0, 0, 1, 1. We choose this, then you'll have 1, 0, 1, 1, 0, 0, 1, 1. And if no, this is not converting, but there exists something, right? You have 0, 1, 1, 1, and this is A. You have to convert it to 0, 0, 1, 1. How do we do so? B is 0, 0, 1, 1. So if you see this adjacent pair, they are different, right? So we can choose them. That will convert to 1, 0, 1, 1. Now you'll have 1, but you cannot choose the same things, right? If we disregard this part, then you have, oh, okay. If we cannot do that, so we have to at least include the other parts in this. So this is fine. I can remove this, and I'll have 1, 1, no, 0, 0, 1, 1, and 0. if we look here, okay, so if we choose the range 2 to 4, then we'll have 0 0, and this will be 0, this will become also 0, all zeros, and then this will become 0 0 1 1, right? And if we choose, so we are getting a cost of 1, right? We do not want that cost of 1, we want to do it in cost 0. So are you able to see? uh let's brute force it. So suppose a is equal to 0 1 1 1, and b is equal to 0 0 1 1, and we have to convert a to b. We're using a cost of 0 only. So one thing is fixed, that we have to choose r from this range, because choosing L and R this from this range does not really work. So let's choose L as this and R as this. These two are fixed. Now what we have to do is that we have to flip those bits. So A will become what? A will become 1 0 0 1, right? Now this is B, this is A. This is fixed. This is not fixed. This is fixed. If we choose this 2 to 4, then this will become 1 1 1 and 0, right? This is our new A. If we choose this operation, if we apply one more operation here, because we need two zeros, and we can get another this. So if we choose the entire thing, then 0 0 0 1. Now we need a 1 here, right? So if we flip this, we'll get 0 0 1 and 0, right? And if we choose this range, this will become 0 0 1. No, this is not working. We'll see this as 0 0 0 1. So basically the idea is that it's just that you have to observe that, uh, so this part is where I got stuck in D2, because in D2 you had to do operations in which you have to actually show those moves in which you are able to convert this A to B, right? But it was pretty, intuitive. I do not have a formal proof for this, but if you run some test cases, then you will see that it is always able to convert to from A to B if it has at least 1 0 and at least 1 1. Otherwise, you just need one more cost, because after performing one more move, you're able to get to a normal string of containing of both ones and zeros, right? What I mean by that is, suppose in this case, let's say here, if you notice that we can just choose, in this case, you can just choose, you have all the ones in the string B, right? So you can perform the operation on string B, by converting this as, you can just reverse this, choose the second most bit, then this will become 101, and then you can choose the entire thing, then that will become 010, right? So you can do it in two moves by performing a cost of one, right? What I mean by that is, suppose you have 1 1 and 1, right? You can choose the middle one. This will convert it to 10 and 1, and now you choose the entire thing, so that will convert it to 010, right? For this case, you can do it in two moves. This is trivial, they are already equal. So in this case, you can also if you can do it in one step by choosing the entire string ls1 and rs2, then this will convert to from 00 to 11, right? And I already showed the case for this, right? The only thing that we are left with is that we are not able to find a sequence of moves for which we are able to convert 0111 0 to 0011, right? But there exists someday, right? Did you get the idea? So the code was pretty simple and it was intuitive as well. There is one, or this is the hard version, right? So basically, what I did here is that if a is already equal to b, then I do not need to perform any operation. I just print 0 and return, right? Because we do not need any moves. Otherwise, we can just count the number of zeros and ones in this both of the strings, right? And the claim is that if x or y, sorry, if the string a or b do not are not of the form zero, all zeros or all ones, then you can do the operation in just zero cost. Otherwise, you can do it in one cost, right? So if x is greater than 0, x is lesser than n, which means that there are both ones and zeros. Similarly, there are both ones and zeros in b as well. Then you print 0, right? Otherwise, you print 1, right? I think like we can, for this string consisting of 0111 0111, this is a, and b was 0011. We can do, if we choose this will convert to 1011. If we choose this two, we'll get 1101. And in the end, if we choose this, no, no, if we choose this will get 0011. Yes, we will get 0011. Yeah. So this is one sequence of moves. Is that the first move is from 1 to 2, that you choose to flip the first two bits. Then you flip 1 and 3, and then you flip 1 and 3. Sorry, the second flip is that you flip 2 and 3, and again then you flip 1 and 3, right? So by performing these sequence of moves, you can get from string A to string B, right? So we are always able to find a sequence of moves that converts string A to string B in by always choosing the extreme points as different points, right? So we are always able to move from string A to string B from by using a cost of 0, right? And for if the string consists of all the same numbers, what will happen is that you have to perform at least one move where you have to alter one bit, right? So if you alter this one bit, you'll get a cost of 1, but now the problem reduces to a simpler version in which you have all the ones and all the zeros. So it's essentially the same thing. Now you can convert a to b in by using a cost of 0, right? The cost is never greater than 1, right? So is the problem clear? There's an issue with the mic. What's the issue? Is my voice not clear? Can we prove constructive algorithms? Uh, I'm not very good at constructive algorithms, constructive problems, but they're, you know, we're able to do them now. Okay, fine. Thanks. We can do 1 4 1 2 2 4. Yeah, you should have told me. Okay, you told me a bit later. We are able to do 1 2 2 3, and 1 3 is also fine. So this is it, and this is the problem where I spend most of my time with in this contest. I don't know, like this was actually the thing that you have to do, that you have to actually perform those moves. You have to print those moves by which you're able to convert from string A to string B. So my idea was that you just do brute force. While the strings are not matching, you just choose the first character L, right? The first index L and the last index R, such that they have different points like 0 1 or 1 zeros, and then you perform the flip operation. Like you uh, perform the flip operation, and because the constraints are low, that n is up to 50, you can just literally flip those bits and then again start finding L and R, right? But I was not able to uh, you know converge this idea, or maybe I was not able to do the implementation part. Somewhere I was stuck. So this was it. And I also read this problem. Did any of you solve this one? This one was kind of deepish. So this and this, both of them are marked for upsolving. I hope you like enjoyed the contest. For 0 1 1, no, the string A was 0 1 1. Yes. Do you guys have any doubt in from A to B? Sorry, A to D. One. Thank you, Mohit. Now is the time. If you guys have any doubt, you can just let me know. I'll be happy to address it. No? Okay. Fine. Thanks for joining. Thanks for watching the PCD. Bye bye.